I'm a chief scientist at VSL, the National Metrology Institute of the Netherlands, and my role is to support the development of primary standards of high accurate reference materials that are used for the calibration of analytical instrumentation in gas analysis, and to coordinate strategic activities, engage with the industry, and to represent VSL in metrology national and international committees. And I'm also the chair of the Euromet, European Metrology Network for Energy Gases. So I'm an expert in energy gases.
What is gas analysis and what is its purpose?
Gas analysis is the leading international symposium and exhibition for gas analysis, which is held every 2 years. And let me say that I am also the co-chair of this event, together with Martin Carré, scientific director in analytical science at Air Liquide. And since last edition in 2022, the event is in Paris, and it is organized by CFM, the Collège Français de Métrologie, with the support of a group of experts from national metrology institutes and industry, such as specialty gas manufacturers and producer of analytical equipment. And it is an opportunity to meet peers, technical staff, producers of gases and instruments, and end users. And it's also an opportunity to learn about the newest developments in gas analytical methods, advances in metrology, and to share knowledge and experience with people which are coming from different countries.
For how long has gas analysis been working on hydrogen? Is it a growing topic?
The event has a scientific program with lectures and posters which are covering research outcomes in different fields where gas analysis is relevant. So energy transition is one of them, but we have also industrial innovation, climate and environment. Since more and more research is focused on the energy transition, the focus of the program has been shifting from the more conventional fuels such as natural gas to more sustainable gases. And of course, hydrogen is one of the top growing topics. And since the last couple of editions, a session is dedicated to hydrogen. And this is also the reason why for the 2024 edition we are organizing the event in partnership with Hyvolution, the French exhibition for the hydrogen industry. And we will devote the first day of the event to presentations that will cover the latest developments for the measurement of hydrogen impurities along the whole hydrogen value chain, and the best metrological solutions for hydrogen in terms of calibration standards, interlaboratory comparisons that improve the accuracy and the validation and the comparability of hydrogen measurement results.
What are the challenges in terms of measurement and metrology for the development of hydrogen?
So to facilitate the scale-up of hydrogen, it is necessary to build a measurement infrastructure that allows fair and safe trade along the whole hydrogen value chain. Quantity and quality of hydrogen are the critical measurements, where quantity is, for example, the amount of hydrogen injected in the gas grid, and quality is the purity of hydrogen, for example, dispensed at hydrogen refueling stations. However, to be able to determine the presence of impurities in hydrogen, there are several challenges that need to be tackled, such as developing and validating analytical methods for the detection of trace level impurities in hydrogen, which needs to be sensitive and accurate. For instance, the determination of sulfurous compounds cannot exceed few ppbs, so we are talking about part per billion levels of sulfurs in hydrogen. Another challenge is developing robust sensor technologies and instrumentation that can be applied in the field. So, for example, working at extreme pressure conditions, like at hydrogen refueling stations up to 700 bars. And another challenge is to produce stable, traceable gas standards, which needs to be used for the calibration of this instrumentation, so that the measurements are accurate. And this is in particular a challenge for components which are very reactive in hydrogen, for example, oxygen.
Why is it important to control the levels of impurities in hydrogen? Are they different depending on the source, like green hydrogen, natural hydrogen?
So the control of the levels of impurities in hydrogen is critical for different market segments. When hydrogen is used as a fuel, it can damage household appliances, engines, such as the PEM fuel cells engines. In the case of the hydrogen-powered fuel cell vehicles, such as taxis, buses, trucks, the quality control of hydrogen is now regulated in Europe, and maximum allowed levels of the impurities in hydrogen are specified in ISO 14687, which is an international standard. And the presence of impurities such as water, carbon monoxide, sulfurs, can damage these fuel cells of the vehicles, and therefore their presence has to be determined and avoided. But hydrogen that is injected in the gas grid as 100% or added to natural gas, which is produced in Europe or it is imported from other regions outside Europe, needs also to be controlled. And this is to make sure that it is safe for the pipelines, that the trade of hydrogen is fair, the energy content is correct, and that, of course, doesn't bring in impurities which can damage then the end user's applications. And indeed, the quality of hydrogen depends on the production process. So the cleanest way to produce it is by water electrolysis, starting from renewables such as photovoltaic or wind energies. And in this case, the main impurities are water and oxygen, which are part of the production process. Other production processes like steam reforming or gasification starts from normally from natural gas. And in this case, the hydrogen which is produced contains more impurities such as hydrocarbons, carbon dioxide, sulfurs, and therefore hydrogen needs to be cleaned before it's used. So you're all invited to come to join the gas analysis symposium and exhibition, which will again take place in conjunction with the Hyvolution.